Wind power. Historical context. The first use of wind power dates back 5,000 years to sail ships on the Nile. Europeans used wind power to grind grains and pump water in the 1700s and 1800s. The first windmill to generate electricity in the rural USA was installed in 1890. Today, large wind power plants are competing with electric utilities in supplying economical, clean power globally. Technological advancements. The average turbine size has increased from 300 kilowatts to 500 to 1,000 kilowatts, with prototypes of multi-megawatt wind turbines under test. Improved turbine designs and plant utilization have significantly reduced wind energy generation costs, from 35 cents per kilowatt-hour in 1980 to less than 5 cents per kilowatt-hour in 1997. Major factors accelerating wind power technology development include high-strength fiber composites for large, low-cost blades, falling prices of power electronics, variable speed operation of electrical generators to maximize energy capture, improved plant operation, pushing availability up to 95%, economies of scale as turbines and plants increase in size, accumulated field experience improving the capacity factor, wind in the world. Global status of wind energy. Wind energy is a promising new source of electrical power in the near term. Many countries promote wind power technology through national programs and market incentives. The International Energy Agency, IEA, supports joint research projects and information exchange on wind power development, funded by 14 countries. By early 1995, more than 25,000 grid-connected wind turbines were operating in IEA member countries, amounting to about 3,500 megawatts of rated power capacity, producing over 6 million megawatt-hours of energy annually. The annual rate of capacity increase is approximately 600 megawatts. Installed capacity and growth rates. According to the AWEA and the IEA, installed capacity in 1995 were 3,552 megawatts, 4,776 megawatts, and 7,308 megawatts, respectively. The most explosive growth occurred in Germany and India, with Germany installing 500 megawatts and India adding 383 megawatts to their wind capacities in 1995. Government policies are significant in promoting renewable energy sources, with examples like the UK's non-fossil fuel obligation program adding 500 megawatts of wind power to the UK's power grid within a decade. Market projections. A 1994 study by the American Wind Energy Association, AWEA, projected that between 1,935 megawatts and 3,525 megawatts of wind capacity would be added in 10 overseas markets by the year 2000, translating to $2 to $3.5 billion in sales. These points provide an overview of the historical context, technological advancements, and the global status and growth of wind energy, highlighting the significant progress and potential in wind power development. Facts. Circa 2024, Europe and India. Europe. Rapid growth of wind power. The wind power sector in Europe has been growing rapidly. Projections for 2,000 wind capacity were met by 1997, achieving targets in half the expected time. By the end of 1997, European countries had installed a total capacity of 4,694 megawatts. 2024 status. By 2024, Europe has installed over 250 gigawatts of wind power capacity. Leading countries in wind energy capacity. Germany and Denmark lead Europe in wind power. Germany experienced a 35-fold increase in installed capacity from 1990 to 1996, reaching 2,079 megawatts in 1997. Denmark also saw significant growth due to favorable policies and incentives. 2024 status. Germany and Denmark continue to be leaders, with Germany surpassing 70 gigawatts and Denmark reaching 7 gigawatts of installed wind power capacity. Targets for future capacity. The European Wind Energy Association adopted new targets: 40,000 megawatts capacity by 2010 and 100,000 megawatts by 2020. These targets are part of a series of policy objectives agreed upon in November 1997. 2024 projections. Europe aims for 400 gigawatts of wind capacity by 2030, contributing significantly to the EU's renewable energy targets. Policy objectives and incentives. Germany and Denmark's growth is attributed to guaranteed tariffs based on domestic electricity prices. The European Union continues to promote wind energy through supportive policies and incentives. 2024 developments. The EU's Green Deal and other policies provide robust support for renewable energy, including significant investments and subsidies. India. Wind power potential and installed capacity. India has a large land area of 9 million square kilometers with a population over 900 million. The total power generating capacity has grown from 1,300 megawatts in 1950 to about 100,000 megawatts in 1998, with an annual growth rate of about 9%. India had 565 megawatts of wind capacity in 1995, with an additional 1,800 megawatts in various planning stages. The government has identified 77 sites for economically feasible wind power generation, with a total generating capacity of 4,000 megawatts. Task 2024 status. India has surpassed 40 gigawatts of installed wind power capacity, with ambitious targets to reach 60 gigawatts by 2030. Government plans and incentives. The Indian government has adopted aggressive plans for developing renewable energy sources, including wind power. Attractive incentives are provided to local and foreign investors to boost wind energy development. The Tata Energy Research Institute's office in Washington, D.C. facilitates links between investors in India and the USA. 24 developments. India continues to offer favorable policies, including tax benefits, subsidies, and accelerated depreciation for renewable energy projects. Distributed power systems and rural electrification. Coal is the primary energy source in India, but its distribution poses challenges due to the concentration of coal mines in specific areas. A significant portion of electricity is used in rural areas where 75% of the population resides, with high transmission and distribution losses of around 25%. Distributed power systems, such as wind plants near load centers, are of great interest to state-owned electricity boards to address these challenges. TASH 2024 status. Distributed renewable energy systems, including wind and solar hybrid projects, are increasingly being implemented to address rural electrification and reduce losses. Major wind energy projects. India has the largest growth rate in wind capacity and is one of the largest producers of wind energy globally. By 1997, India installed 1,000 megawatts of wind power, ranking among the top 5 countries in wind energy generation. Government plans include expanding wind power infrastructure and encouraging private sector participation. 2024 developments. Significant projects like the Muppandal wind farm and new offshore wind projects are being developed, with several multi-GW projects in various stages of planning and execution. These points provide an updated overview of the historical context, current status, and future potential of wind energy in Europe and India, highlighting significant progress and ambitious targets for 2030. Potential unexplored technologies for wind energy in India. Circa 2024. Offshore wind farms. Potential. Offshore wind farms have the potential to generate significant amounts of electricity due to stronger and more consistent wind speeds over the ocean. Countries with technology. United Kingdom, Denmark, and the Netherlands are leaders in offshore wind technology. These countries have developed advanced offshore wind turbines and floating platforms suitable for deep waters. Floating wind turbines. Potential. Floating wind turbines can be deployed in deeper waters where traditional fixed-bottom turbines are not feasible. This technology can expand the areas available for wind power generation. Countries with technology. Norway and Japan have pioneered floating wind turbine technology. Norway's Equinor has developed the Hywind project, and Japan has several pilot projects demonstrating the feasibility of floating wind farms. Hybrid wind solar systems. Potential. Combining wind and solar power generation can provide a more stable and reliable energy supply. Hybrid systems can optimize land use and enhance the overall efficiency of renewable energy installations. Countries with technology. Germany and China are advancing hybrid wind solar systems. These countries have integrated wind and solar technologies into single projects, showcasing the benefits of combined renewable energy systems. Wind energy storage solutions. Potential. Efficient energy storage systems can address the intermittency of wind power and provide a stable energy supply. Advanced batteries, flywheels, and other storage technologies can store excess wind energy for use during periods of low wind. Countries with technology. The United States and South Korea are leaders in energy storage technologies. The U.S. has made significant advancements in battery storage, while South Korea is known for its large-scale energy storage systems. Small-scale wind turbines for distributed generation. Potential. Small-scale wind turbines can be used for distributed generation, providing power to remote and rural areas. These turbines can be installed on individual properties or small communities to enhance energy access. Country. The United States and the United Kingdom have developed small-scale wind turbines for distributed generation. These countries offer technologies suitable for decentralized power generation in off-grid areas. Smart grid and wind integration. Potential. Smart grid technologies can improve the integration of wind power into the grid, enhancing grid stability and reliability. Advanced monitoring and control systems can optimize the use of wind energy. Countries with technology. Germany and South Korea have implemented advanced smart grid technologies. These countries have developed systems for efficient wind power integration and grid management. Vertical axis wind turbines. Potential. VAWTs offer several advantages over traditional horizontal axis wind turbines, including lower noise levels, easier maintenance, and better performance in turbulent winds. They are suitable for urban and suburban areas. Countries with technology. Canada and Italy are leaders in VAWT technology. Companies in these countries have developed innovative designs that can be deployed in various environments, including cities. Advanced wind turbine materials. Potential. Using advanced materials like carbon fiber and new composites can reduce the weight and increase the durability of wind turbine blades, enhancing their efficiency and lifespan. Countries with technology. The United States and Japan are at the forefront of developing advanced materials for wind turbines. Research institutions and companies in these countries are exploring new materials to improve turbine performance. By exploring these potential technologies and collaborating with countries that have expertise in these areas, India can enhance its wind energy capacity and address the challenges of integrating renewable energy into its power grid.